Hello everyone, today I'm going to introduce biodiesel production, why we are interested in producing biodiesel production, and what are the common methods that can be used for biodiesel production, and also what kind of materials they are suitable for producing biodiesel. I will speak in English, and then in a separate video I will speak in Arabic. So vegetable oils can be used as fuels in engines, and Mr. Radolf Diesel, the French German engineer, used the peanut oil as fuel. However, using vegetable oils as engine fuel can cause several problems. For example, knocking on the injectors, carbon deposit on intake valves like this one here. If you look at these valves here, you can find a lot of deposits. And also it can also produce oil ring sticking and thickening and gelling of lubricant oils, and of course lubricants or lubricating problems. All of this actually problems arise from the fact that the vegetable oils has very high viscosity. So if you look at here, this is basically a comparison between characteristics or properties of number 2 diesel, which is regular diesel, and the biodiesel and vegetable oil. For example, here, the viscosity of biodiesel is about 5.7 centistocks, and the vegetable oil is something like 45. So basically, this is problems arise from this kind of high viscosity oils. So what do we need to do? We need actually to reduce the viscosity, basically. So what reduce the viscosity, and this can be done through the biodiesel production. So what is biodiesel? Biodiesel is a liquid biofuel produced from vegetable oils, used cooking oils, or animal fats. So basically, you need some kind of fat to produce biodiesel. It's, of course, it can be used for diesel engines. It's not really for gasoline engines. So it can be used alone or blended with regular diesel. For example, if we have diesel fuel with a certain amount of biodiesel, this can be referred as BX. B here, this is a fraction of the biodiesel that can be added to the regular diesel. So basically here, what do we need here? So basically, if we say that something like X is the percentage, sorry, the X is the percentage of biodiesel in the blend. For example, if you have B5, indicating that a blend with 5% biodiesel and 95% of diesel. So again, and if we have B100, this indicates that it's just pure biodiesel. Okay, so again, this is just to give you an idea about how can we use biodiesel in engines. There are several advantages of biodiesel. It's, of course, it's a renewable fuel and has lower toxicity compared with diesel fuel. And of course, it can be degraded more rapidly compared with diesels. And it can also emit lower emissions like carbon monoxide, particulate matter, polycyclic aromatic hydrocarbons, aldehydes, and also has low health risk because it's actually came from organic materials. And of course, it can also has less emissions of carcinogenic substances and no sulfur dioxide emission and excellent properties as lubricant. And of course, for most of, or maybe majority of the engines, they don't need any modification to use the blends of biodiesel or even 100% of biodiesel. Okay. Of course, the disadvantage, it might actually have also some advantage, as I mentioned. So it's a higher fuel consumption. Of course, this is because the low calorific value than the diesel, and it can also emit more nitrous oxide compared with the diesel, and has higher freezing point than diesel. This means that it will be a problem if you would like to use diesel in cold weather, and less stable than the diesel because it's more biodegradable, and maybe longer-term storage for more than 6 months need to be watched, and it's not really recommended. Also, may degrade plastic and natural rubber gaskets and hoses, and therefore Teflon component is recommended in this actually kind of hoses or gaskets. Okay. What kind of biodiesel feedstocks they can be used? For example, in the US, you can find soybean, corn oil, used cooking oils, and canola oil and animal fats. Of course, there are some other. Again, it's basically you need some kind of fat or some lipids to produce biodiesel. There is some also some kind of algae. Maybe we will talk it in another video or some time later. So, for example, again, in the US, the majority is come from soybean, about 54%, and corn oil, 15%. Used cooking oil and yellow grass. This is basically here the picture. This cooking oil and yellow grass. This can be come from what they call it FOG or FOG, which is fat, oil, and grease. This can be collected from kitchens or from restaurants or from some kind of, this was they call it grease trap. And here this is the yellow grease, for example. This come from the waste cooking oil, and here this also sewage grease interceptors. This also collect some kind of sewer grease, and this, of course, it can be collected in the FOG container, and then can come to, of course, to produce biodiesel. Here I am actually citing a nice review about how to use this kind of cooking oil, used cooking oil and yellow grass to produce biodiesel. Okay, so again, this is a yield of from different feedstocks. For example, if you have soybean, you can actually expect something like 56 gallon biodiesel per acre, and this sunflower maybe 82, and maybe go up until oil palm maybe 508. And of course, if you compare with algae, you will find something like 10,000 gallon per acre. However, algae has some challenges for cultivation or for harvesting, but maybe this is not really our topic today. It's just to give you some perspective about what kind of feedstocks that can be used. Okay, what are the methods that can be used for biodiesel production? There are a few methods. Maybe the most common ones are microemulsions, pyrolysis, or what they call it thermal cracking, and the most common method is transesterification, or they call it alcoholysis. Alcoholysis, this actually is the most common one. This is basically, if you any lab can be reduced, and even for commercial, actually they use also transesterification. And in this transesterification, biodiesel is produced by chemically reacting the feedstock, which is our lipid, with an alcohol in the presence of catalyst. Why we do that? So basically, again, this transesterification reaction here, we have triglyceride, which is this formula, and we react it with alcohol, most likely methanol or maybe other like ethanol. And of course, we have to have catalyst. This catalyst can be sodium hydroxide or potassium hydroxide, or even some other like enzyme also can be used as catalyst, among other materials that can be used for speeding up the reaction. What happened here, this kind of triglyceride is reacted with the methanol and produce this kind, what they call it, mixture of fatty esters, and then the other product is glycerol. So the fatty acid the fatty esters here, this basically is the biodiesel, which if you look at this kind of funnel, you will find the biodiesel on the top part of the separatory funnels, and the bottom part is glycerol. The glycerol, actually, this good also byproduct of this whole thing, that it can contain the extra methanol, because theoretically we have to have 3 moles of alcohol, but in real life we have to have extra alcohol, so that the reaction will not be reversible, and we will have only one direction to produce biodiesel and glycerol. So again, this glycerol layer can contain the extra alcohol, and of course the catalyst also will end up, majority of it will be ending up in the lower part here as with the glycerol. The glycerol, of course, has many applications, like cosmetics, or maybe can be used for feedstock for other industries, and of course can be also be added to fortify the biogas production. So some actually research has been done to add this glycerol to anaerobic digester, so that you can actually collect more gas from the digester, especially for material with low biogas yields. Okay, what happened here? This is the mass balance. If we have 100 kilogram or 100 pound of oil, it needs about 10 pound of methanol. And of course, we will have some kind of catalyst. Maybe we need about 1 kilogram or less of catalyst, is either sodium hydroxide or potassium hydroxide. This will produce about 100 pound of biodiesel and 10 pound of glycerol. So basically, of course, yeah, if you have 1 kilogram of catalyst, it will be ending up mainly in the glycerol. Of course, there may be some in the biodiesel that can be washed out in a next step, but this is just a very simple representation of how to use biodiesel. And I would like to thank you, and if you have any comments, I will be happy to answer them. Just put them in the comments in this video. With that, see you in the next video.